Hi, it's me, Dr. Prasad Puthiyillam, on my YouTube channel, My Intuition, regular and entrance coaching classes for chemistry and learning mathematics. This is class number 4 of Basic Concepts of Chemistry, Dalton's Atomic Theory, Atomic and Molecular Masses, Formula Mass. Dalton's Atomic Theory. The atom, the word atom, meaning atomio or indivisible, was not introduced recently. It was introduced during 460 to 370 BC by a Greek philosopher Democritus, and a new system of chemical philosophy was published by John Dalton in 1808. It states that matter consists of indivisible atoms. All atoms of a given element have identical properties, including identical mass. Atoms of different elements differ in mass. Compounds are formed when atoms of different elements combine in a fixed ratio. Chemical reactions involve reorganization of atoms, and they are neither created nor destroyed in a chemical reaction. So this states Dalton's atomic theory. So atomic mass in the present system, it is based on the carbon 12 as the standard. Earlier they used hydrogen as the standard. Now we'll continue with carbon as carbon 12, the isotope copper carbon 12 is one of the isotopes of carbon, carbon 12, carbon 13 is the, carbon 14 is the. Okay, so considering the isotope carbon 12 as the standard, we can exactly assign as 12 atomic mass unit for carbon 12, and masses of other atoms are given relative to this standard. So example, one atomic mass unit is defined as the mass exactly equal to 1/12 of the mass of one carbon 12 atom, or 1 AMU is calculated as 1.66056 multiplied by 10 to the power minus 24 gram per atom. Okay, the mass of carbon 12, if you calculate, that is molar mass divided by Avogadro number. This we'll discuss in coming classes. So just for to understand what is 1 AMU, I calculated this, that is 12 divided by 6.022 multiplied by 10 to the power 23, it becomes 1.993 to 10 to the power minus 23 gram per atom. Therefore, 1 AMU, it is 1/12 of mass of carbon. We got the mass of carbon 12 here. Okay, therefore, one atomic mass unit is 1/12, 1 by 12 multiplied by 1.993 10 to the power minus 23, it becomes 0.166056 multiplied by 10 to the power minus 23, or we can write it as 1 AMU as 1.66056 multiplied by 10 to the power minus 24 gram. So 1 AMU we calculated, that is 1.66056 into 10 to the power minus 24 gram. So we'll calculate the AMU of hydrogen. So the mass of atom of hydrogen is calculated as 1.6736 multiplied by 10 to the power minus 26, that is mass by Avogadro number only. Okay, so in terms of AMU, the mass of hydrogen you can calculate as 1.6736, that is mass of atom of hydrogen, into 10 to the power minus 24 divided by 1.66056 into 10 to the power minus 20 becomes 1.0080 atomic mass unit. In terms of AMU, the mass of oxygen 16, the isotope of oxygen 16O, it is 15.995 AMU. Even this atomic mass unit is getting replaced by U, that is unified mass, and the atomic masses are calculated as average atomic mass if the element have isotopes. Say example, average atomic mass considering carbon. Carbon, it has got 3 isotopes as I mentioned earlier, that is carbon 12, carbon 13 and carbon 14. Their relative abundance, availability or presence in earth crust, that is calculated in terms of percentage, that is 98.892 for carbon 12 with atomic mass 12, and 1.108 for carbon 13 with atomic mass of 13.00335, and very low value, that is 2 into multiplied by 10 to the power minus 10. Okay, that is carbon 14 with atomic mass of 14.00317. So if you calculate the average, first you need to divide by 100, this is percentage, and multiply by 12 and keep on adding these three values, you will get the average, taking the average. Therefore, it becomes 0.98892, that is 98.892 divided by 100. Okay, so 9.98892 multiplied by 12, 1.108 becomes 0.01108 multiplied by 13.0035 plus 2 into 10 to the power minus 10 divided by 100 becomes 2 into 10 to the power minus 12 multiplied by 14.00317. Multiplying and adding, will be getting the value 12.011, that is the average atomic mass of carbon. Okay, so carbon 12 in terms of average atomic mass, if we consider, it becomes 12.011. Now molecular mass. Molecular mass is the sum total or sum of atomic masses of the elements present in the molecule, and we calculate their molecular mass by adding, and even the number of atoms present also we need to consider. Therefore, it is obtained by multiplying the atomic mass of each element by the number of atoms and adding them together. So example, molecular mass of water H2O, it becomes 2 hydrogen, 2 into 1.008 plus 1 oxygen, that is 1 into 16 becomes 18.02 U, that is unified mass. Molecular mass of methane can be calculated as 16.043, so 1 carbon and 4 hydrogen. Molecular mass of glucose, that is 6 carbon, 12 hydrogen, 6 oxygen. If you multiply and add up, you'll get 180.162 U. In case of atoms or molecules like sodium chloride, which exist as ion, sodium chloride, potassium chloride, all are example, that exists as ions, that is Na plus, it is surrounded by 6 Cl minus, and vice versa, 1 Cl minus is surrounded by 6 Na plus. Therefore, such cases, okay, so NaCl take as the formula. NaCl is the formula of sodium chloride. It is used to calculate the mass instead of because as sodium chloride does not exist as single entity, but still we have to consider as the formula for calculating the formula mass. Therefore, we call it as formula mass. The formula mass of sodium chloride, it is atomic mass of sodium plus atomic mass of chlorine, that's 23.0 U plus 35.5 U becomes 58.5 U. That's about formula mass. Okay, thank you very much for watching this video. Please do subscribe my YouTube channel, My Intuition, and support me. Have a nice day.